For almost all of human history, a simple cut, a sore throat, or a tiny infection could become a death sentence. Before antibiotics, humanity lived in constant fear of invisible killers. Pneumonia, tuberculosis, scarlet fever, syphilis, sepsis. Millions died from wounds that today would barely require a doctor's visit. Even the greatest surgeons in history were helpless against bacteria. Then, by accident, inside a cluttered laboratory in London, a forgotten petri dish changed the future of civilization forever. This is the story of antibiotics, the story of penicillin, the story of the mold that saved the world. To understand the miracle of penicillin, you must first understand the horror that came before it. 19th century hospitals were terrifying places. The air smelled of blood, smoke, sweat, and death. Doctors often moved directly from one patient to another without washing their hands. Surgical tools were reused repeatedly. Bacteria were everywhere, but nobody knew they existed. For centuries, people believed disease came from bad air, evil spirits, imbalanced body fluids, or divine punishment. Many physicians still believed illness spread through mysterious poisonous vapors called miasma. The real killers remained invisible. Children died constantly. Ear infections killed. Strep throat killed. Minor cuts killed. Simple childbirth infections killed mothers by the thousands. Entire families could vanish from infections modern medicine now cures in days. War was even worse. In many battles, more soldiers died from infection than from bullets. A man might survive the battlefield, only to die days later from bacteria entering a wound. Amputations became common because doctors had no way to stop infection from spreading. Surgeons often operated at terrifying speed, not because it improved precision, but because reducing time reduced agony. One disease haunted humanity more than almost any other: tuberculosis, known as consumption. Victims slowly wasted away over months or years, coughing blood, growing thinner and weaker. Entire cities feared it. Entire families were destroyed by it. No cure existed. Humanity could not defeat bacteria until humanity discovered bacteria. In the 1600s, early microscopes revealed something shocking. Tiny living organisms existed everywhere. An invisible universe surrounded humanity. But many scientists still doubted these discoveries. Everything changed in the 19th century. French scientist Louis Pasteur proved microorganisms caused fermentation and disease. Suddenly, germ theory emerged. Disease was not magic. It was biological. And if microbes caused disease, perhaps microbes could also be stopped. Surgeon Joseph Lister transformed surgery forever. He introduced antiseptic procedures using carbolic acid. Doctors finally began sterilizing instruments and cleaning wounds. Deaths dropped dramatically, but infections still killed millions, because antiseptics could clean surfaces. Yet once bacteria entered the body, medicine remained powerless. Scientists began dreaming of a miracle, a substance that could kill bacteria without killing the patient. German scientist Paul Ehrlich imagined a magic bullet, a chemical weapon that targeted disease specifically. He helped develop one of the first antimicrobial drugs for syphilis. It was a breakthrough, but dangerous and imperfect. The true antibiotic age had not yet arrived. Scientists around the world searched desperately for antibacterial compounds. Most failed. Some chemicals killed bacteria, but poisoned patients too. Others simply didn't work inside the human body. The challenge seemed impossible. In 1881, on a farm in rural Scotland, a boy was born who would accidentally change human history. Alexander Fleming grew up surrounded by nature: streams, soil, plants, animals. The natural world fascinated him. He was quiet, observant, and unusually curious, traits that would later become legendary. Fleming eventually studied medicine in London. He became known for careful laboratory work and sharp observation skills. Unlike many scientists, he paid attention to small, unexpected details. That habit would change everything. The First World War became one of the deadliest laboratories in history. Mud, rats, rotting corpses, exploding artillery. The trenches of World War I created perfect conditions for infection. Soldiers suffered horrific wounds contaminated by dirt and bacteria. Even minor injuries could become fatal. Fleming worked with wounded soldiers during the war. He saw countless men die not from the initial injury, but from infection afterward. Antiseptics often damaged healthy tissue while failing to stop bacteria deep inside wounds. Fleming became convinced medicine desperately needed something better. One day, Fleming noticed nasal mucus accidentally dripped into a bacterial culture. Oddly, the bacteria died. He discovered lysozyme, an enzyme naturally present in tears, saliva, and mucus that kills some bacteria. It was not powerful enough to cure major diseases, but it proved something critical. Natural antibacterial substances existed. Nature itself fought microbes. Then came the accident. Fleming's laboratory was famously untidy. Petri dishes stacked everywhere, cultures left sitting for days. Many scientists might have considered the room careless chaos. But within that chaos, history waited. In September 1928, Fleming returned from vacation to St. Mary's Hospital in London. He began sorting through old bacterial cultures. Most scientists would simply throw contaminated dishes away. But Fleming noticed something strange. One dish had been contaminated by mold. Around the mold, the bacteria had disappeared. A perfect clear circle surrounded it. The mold was killing bacteria. Fleming stared carefully at the dish. That moment became one of the most important observations in medical history. Many people might have ignored it. Many might never have noticed. But Fleming asked the question that changed civilization. Why are the bacteria dying? The mysterious mold belonged to a common fungus. The mold was identified as belonging to the genus Penicillium. Fleming named the antibacterial substance it produced penicillin. At first, nobody realized how revolutionary it would become, not even Fleming himself. Fleming tested penicillin against dangerous bacteria. The results were astonishing. Staphylococci died. Other harmful bacteria died too. Yet penicillin appeared surprisingly harmless to animal tissue. It seemed almost magical. But there was a massive obstacle. Penicillin was unstable and difficult to purify. Fleming could not isolate enough usable substance. The discovery was extraordinary, yet practical medicine still seemed far away. One of history's greatest discoveries was almost forgotten. Fleming published his findings in 1929. Almost nobody paid attention. Why? Because penicillin was difficult to produce, scientists could not easily extract or stabilize it. Medical research moved on. For years, the discovery sat mostly ignored. The world came dangerously close to missing penicillin entirely. Had events unfolded differently, millions more might have died. A decade later, another group of scientists reopened the forgotten door. At the University of Oxford, scientists Howard Florey and Ernst Boris Chain became interested in antibacterial substances. They rediscovered Fleming's old paper. Unlike others, they saw enormous potential. The Oxford team worked obsessively. They experimented day and night trying to purify penicillin. The process was painfully difficult. Penicillin was fragile. Tiny amounts required enormous labor. But slowly, they succeeded. In 1940, the impossible suddenly became real. Researchers infected mice with deadly bacteria. Half received penicillin, half did not. The untreated mice died. The treated mice survived. The room reportedly fell silent. Penicillin worked. Truly worked. The age of antibiotics had begun. Now came the greatest test of all. In 1941, a British policeman named Albert Alexander became one of the first humans treated with penicillin. A tiny scratch from a rose thorn had led to catastrophic infection. His face and body filled with abscesses. He was dying. Doctors administered penicillin. The results were astonishing. Fever dropped. Abscesses shrank. Condition improved dramatically, but there was not enough penicillin available. Supplies ran out. The infection returned. Alexander died. Yet doctors had witnessed something extraordinary. For the first time, a deadly bacterial infection had been pushed back by a true antibiotic. The Second World War transformed penicillin from laboratory curiosity into global salvation. World War II created desperate urgency. Infections killed huge numbers of soldiers. Governments realized penicillin could save countless lives. Britain and the United States launched massive production programs. Factories began cultivating penicillium mold on enormous scales. Scientists searched for better strains. Fermentation technology rapidly improved. Production exploded. What once required months in laboratories could now be produced industrially. By the time Allied forces landed in Normandy in 1944, penicillin accompanied them. Countless soldiers survived wounds that would previously have been fatal. Doctors called it miraculous. After penicillin, medicine entered a new era. Scientists discovered more antibiotics: streptomycin, tetracycline, erythromycin, vancomycin. Many came from soil microbes. Nature itself became humanity's pharmaceutical library. Suddenly, surgeries became safer. Organ transplants became possible. Chemotherapy became survivable. Childbirth became dramatically safer. Minor infections stopped being death sentences. Human life expectancy rose. Civilization itself transformed. Diseases that terrorized humanity for centuries suddenly lost their power. Pneumonia had once been called the old man's friend because it killed so many elderly people quickly. Antibiotics changed that. Syphilis once devastated entire populations. Penicillin became one of the greatest weapons against it. Children who once would have died from simple infections now survived routinely. Parents experienced something previous generations rarely knew: confidence their children might actually live to adulthood. But even as the world celebrated, Alexander Fleming issued a warning. Fleming understood evolution. He warned that improper antibiotic use could create resistant bacteria. If antibiotics were overused, microbes would adapt. The warning proved prophetic. The miracle of antibiotics created a dangerous illusion that humanity had permanently defeated bacteria. Bacteria reproduce incredibly fast. Mutations occur constantly. When antibiotics kill weaker bacteria, resistant survivors remain. Those survivors multiply. Over time, entire bacterial populations evolve resistance. Today, humanity faces dangerous resistant bacteria, sometimes called superbugs. Some infections no longer respond to multiple antibiotics. Hospitals worldwide battle these evolving threats. The war never truly ended. So how does penicillin kill bacteria? Penicillin attacks bacterial cell walls. Without strong walls, bacteria burst under pressure and die. Human cells lack those same wall structures. That is why penicillin can target bacteria more selectively than many earlier chemicals. It was one of medicine's first true precision weapons. People often say penicillin was discovered by accident. That is true, but incomplete. The mold contamination was accidental, but the discovery required something rare: curiosity, discipline, knowledge, observation. Countless scientists might have thrown the dish away. Fleming noticed the impossible. That changed history. No one knows exactly how many lives antibiotics have saved. The number may exceed hundreds of millions. Every day, across Earth, antibiotics quietly save lives. After surgeries, during childbirth, inside emergency rooms, on battlefields, in ambulances, inside neonatal units, inside ordinary homes. Most people rarely think about it, yet modern civilization depends on antibiotics constantly. Without them, the modern medical system could collapse. Imagine a world without antibiotics. Minor cuts become deadly again. Routine surgeries become terrifying. Cancer treatment becomes far more dangerous. Organ transplants become nearly impossible. Child mortality rises dramatically. Life expectancy falls. Modern medicine rewinds backward by generations. One forgotten petri dish helped prevent that future. In 1945, the world recognized the magnitude of the discovery. Alexander Fleming, Howard Florey, and Ernst Boris Chain received the Nobel Prize in Physiology or Medicine. The award honored not just a scientific breakthrough, but one of humanity's greatest victories against disease. The story of antibiotics is not over. It is still being written. Scientists now search for new antibiotics in deep oceans, rainforests, soil, fungi, even bacteria themselves. Because microbes continue evolving, and humanity must evolve too. Inside every hospital, every operating room, every pharmacy, the legacy of penicillin survives. A forgotten mold, a curious scientist, an accidental contamination, and a discovery that transformed human survival itself. History is often changed by emperors, wars, and revolutions, but sometimes history changes because one person notices something strange inside a tiny dish. covered in mold, and from that moment forward, the world is never the same again. Thanks for watching. If you enjoyed this video, don't forget to hit that like button and subscribe to the channel for more content like this. Turn on the notification bell so you never miss an upload, and let me know your thoughts in the comments below. See you in the next video.